Gateways and trunks, connecting CME to other voice systems. Now, before we jump straight into this new material in this nugget, I want to take a moment, set a little pacer, and if you've been going through these nuggets in order in this series, I want to talk about where we've been to kind of lead up into here and where we're about to go. We started off this whole series in just a general welcome, talking about voice over IP, why is it cool, what's the big deal about it. Then we looked at the historic voice, talking about the legacy PBX systems and how we can connect to them and how they worked and converting analog to digital and all those pieces that came from the history of voice. Then we transitioned into voice over IP. Talked about the pieces that build a Cisco voice network, from the IP phones over to the routers. That would be a router, obviously a non-Cisco router there. A Cisco switch. All of the pieces that build it, inline power, and we moved from there into the network infrastructure, getting the infrastructure ready to connect the voice up. And then we talked about a massive topic, which was CME, configuring a CME router to support a small business environment, from the ePhones themselves to the ePhone DNs, the directory numbers that's on those devices, and the features that everybody's come to know and love from our networks, from shared lines to music on hold to transfer, conference, all these different capabilities that are on the phone. We talked about all of them. So up to this point, we have now configured the local area network, and that leads me into where we're going now. It's time to reach out to other networks. That may be communicating to the PSTN, if we have a PSTN connection. Could be a connection to maybe a PBX. A lot of times, companies don't move completely to voice over IP all at once. They'll keep the PBX in place for the majority of the company and maybe just bring up a small segment of the company, like the IT department, running voice over IP. And we may need to connect out to the PBX system and bridge from the existing company to the new company that is slowly growing, and slowly but surely we move devices over into the voice over IP network. This could, and where we're going to be going a lot in the future, be connecting to a voice over IP network. Another one. It could be yours. It could be a remote office that maybe is also running CME, or maybe the full Cisco Unified Communication Manager solution, where you have a call manager running that's supporting thousands or tens of thousands of phones over here. And we're bridging the two networks together so we can have seamless voice over IP communication. Or this could be someone else's voice over IP network. This could be one of the next generation PSTN providers. A lot of PSTN carriers are moving over and becoming voice over IP communication based, and they're a lot cheaper and a lot more flexible than traditional PSTN vendors. So, as we go through here, we'll be talking about the different gateway types that you can get, which is different interfaces we can put in our CME router. Difference between analog and digital connectivity, what kind of interfaces make that. And then for this last piece, when we're communicating to a voice over IP segment, what protocols are making that happen? We're going beyond TCP/IP here into voice-specific protocols that can communicate between voice over IP networks. First thing we'll discover is, as we talk about connecting to other voice networks, we see a terminology shift. We're moving from the idea of a voice router, meaning like a CME router that's routing between networks and things like that, into terminology that you'll see voice gateways. Voice gateways, I guess when you think of a gateway, a lot of, and this is a common question I get when I teach CCNA classes or CCENT, just the beginning Cisco level classes. I have a bad habit of using router and gateway almost interchangeably. Like I'll say, oh, we have a router, or that's the default gateway, we're going through our gateway, and all those kinds of terms. And usually I get the question, well, what's the difference between a router and a gateway? And it usually catches me off guard every time, because I have to stop and think, and I go, well, they're pretty much the same thing. They're the same device anyway. But a gateway really transitions between network types, whereas a router perhaps is just routing between IP networks. Back in the day, a gateway would be considered, maybe you're running TCP/IP on one side, and you're communicating over an IPX SPX network over on the other side. So this gateway is transitioning between protocol types. Well, now in the voice over IP realm, our gateways are those that transition between voice communication types. So maybe you have a voice over IP network over here on the left, and you're transitioning to the PSTN over on the right. Well, there's two major gateway types that you can have, an analog or a digital voice gateway. Now this one gateway could be both, all depending on the type of interfaces that it have. An analog voice gateway is where you have interfaces installed that are analog connectivity and you get one call per port. Now we're going to dive into what those interfaces are in just a moment, but this would be, if I'm connecting to the PSTN, something like an FXO port, where I have a single FXO connection to the PSTN. It can receive one call at a time to an internal phone over here, or it could send one call at a time from an internal phone on the inside. But each line that I add is a additional reoccurring monthly charge and a completely separate set of two wires. Think back to our historic voice connectivity, why analog connectivity had to be migrated. The wires were just too crazy. We needed more than one call per port. So that's where the digital voice gateways come in. And this is where we typically see our T1 connections or E1 connections when we're getting into PRI and the CAS and different signaling types that we have over the digital voice ports. The key that I want to talk about now is these interfaces on the router will be able to receive more than one call per port through the different types of signaling they support. So let's now explore the interfaces that makes each one of these voice gateways work. With the analog world, we'll start off with foreign exchange station ports. These are interfaces that we can add to our router. By the way, these interfaces are normally called, well, always called, VIC cards, voice interface cards. So I can buy a VIC card, and most of the time, the exact model number is VIC2-2FXS, or this one would be a VIC2-4FXS. Where you actually get 4 voice interfaces per card. I'm amazed that they can squeeze 4 interfaces on one of these small form factor cards. The things are like aluminum foil between these. It's so thin. But this gives you the ability to connect, keyword, a station, an analog station to the router, and the router will convert it to a voice over IP device. This is really useful for, old analog phones, and you might go, well, come on. I mean, where would we have one of these? These don't sit on people's desks. Well, think about like emergency phones. You might have emergency phones in parking garages or in elevator systems that are, that people can pick up the phone for an elevator. A lot of times replacing those phones with voice over IP devices would be expensive or impractical, because emergency phones could be sitting outside, in places where the weather can hit them. And these phones, some of the lower end ones, are designed to handle that because they can get wet and they're not going to break and all that kind of stuff. So you might have analog phones or modem connections. Modem connections connected to an analog port, or fax machines. Fax machines, to get IP faxes that send and receive IP faxes, is expensive, and a lot of people they're used to the fax machines that are sitting in the office right now, those multifunction all-in-one devices. So you can just run a single FXS port out to that device. Now I want to make sure I mention that FXSs are so popular that there are multiple ways that you can add them. Adding VIC cards to your routers is one of those. You can do that, but it's kind of expensive to do it that way. There's other ways. You can actually buy, there's a device, and did we talk about this? We may have. I think we did. The ATA 186 or 188. I know we did. We talked about these when I covered the devices that build a voice network. But just to review, this is a little box. It's about, yay big. Not to scale. It's very small. I'm trying to think. It's like, I don't know, something very small. Like a... well, I'll just put dimensions. Probably about 8 inches, long or so. It's not big. So on this device, the ATA 186 has a single Ethernet port and 2 FXS ports where you can plug it into these different devices. The only difference is the ATA 188 has 2 Ethernet ports. It's kind of a built-in switch, so you can get one ingoing, one incoming, and one outgoing, where I can plug in a computer or something like that. So these are pretty cheap, and they're a great way to just wherever you've got an Ethernet jack, like if you're in one of those copy rooms in your businesses, there's an Ethernet jack on the wall. You can just plug in one of these devices and connect it to the analog devices in that area. There's also, if you need a lot of them, a whole bunch of FXS ports, there is a specific, I don't want to call it a router, we'll call it a gateway called VG224 or VG248. And what these have, and those of you from the legacy PSTN world or PBX world will recognize the type of connectors. They look like, to the data people, big scuzzy connectors, but these are known as amphenol connectors. And what you do is you get the special cable that plugs into that, and each amphenol connector is able to handle 24 FXS ports. This actually goes up to a punch-down block where you have 24 individual lines that can go to fax machines and phones and that kind of thing. VG224 has one amphenol connector and an Ethernet port. It's kind of the same thing as this. It's just with a whole bunch of ports. So 24 or 48. This one has two amphenol connectors, 48 ports of FXS connectivity. Foreign exchange office ports, on the other hand, are only installed inside of a router. There's no other little boxes or devices that you can get these ports in. Foreign exchange office is not designed to connect to a station like FXS is. It's designed typically to connect to the central office. That's how I always remember office. We're outgoing here. These ports will be expecting, where you have FXS ports, not typically a WAN link, but FXS ports that plug into an analog phone are going to provide dial tone to that device. So essentially, an FXS port sends dial tone. A foreign exchange office port will expect to receive dial tone. Because if, for example, you have an analog port in your company wall that connects to the PSTN, that, when you plug in a device, will get dial tone. So FXO expects to receive dial tone, and these are our trunk lines. You can think of these as like analog trunks that allow us to connect to the PSTN. Or you can do kind of a positive-negative relationship, like I have an FXO port over here that I could plug into a station port. They don't usually call it FXS, but we'll do it for now. We'll call it a station port on the PBX system. This one is sending dial tone, right, just like it does to the phone. This one is receiving dial tone, so you can use this as a trunk, a type of trunk, to the PBX system. So here's a big picture perspective. Maybe your company has a PBX. They've moved a small amount of users, we'll say 10 users, over to a voice over IP system. Well, what you can do is you can bridge the two systems by doing an FXO to station port match on the PBX system. So when somebody on the PBX dials, we'll say 511, anything up at a little dot there, the PBX can be programmed to send it out, or ring, if you will, that interface. This comes over here, the router picks it up and sees an incoming call for 5111, which is this phone, and it just routes it right through. So these phones can then receive calls from the PBX system, and you can configure the router anytime somebody dials, whatever numbers are on the PBX system. We'll say 500 dot, or 50 dot dot. There's probably a bunch of phones over here. Anytime you dial that, this picks up and sends it out this line, and that's how you can establish a trunk between the two. Likewise, you can also use this to send and receive incoming and outgoing calls from the PSTN. These are your analog trunks, your analog ports to get PSTN connectivity for your company. One more thing I want to mention before we move on to digital connectivities is FXS and FXO are the most common analog voice ports that you're going to run into 99% of the time. But there is one more that is out there, and it is known as E&M analog interfaces. What these are, remember, analog. How many calls per port? One. A nice little slide there on my one. One call per port always. And you can get these E&M, typically called ear and mouth or earth and magneto. There's different definitions in the PBX realm, where PBXs come specifically equipped with these E&M ports. These are designed for nothing but trunking. So if you want to do this kind of thing, you can buy a special E&M interface that communicates with the E&M interface on the PBX. Now, normally you're going to do this kind of trunk, an FXO to FXS match, because all PBXs have FXS ports. However, if they have E&M ports, you can also use this. This is just another alternative for you. You won't usually go out and buy E&M interfaces for a PBX to do this if it doesn't already have them, because these are typically very expensive. So you'd rather save the money and do an FXO to FXS match. But just keep in mind there are these E&M interfaces out there that can be used to connect to a PBX system in a trunking fashion. As you move into the larger business environments, mid-size to large business, you move into the realm of digital voice ports. And this, going back to our historic voice connectivity, is where you get your T1/E1 interfaces, like you can see right here. This, I know it's hard to see because that little thumb screw is in the way, but this actually says VWIC, which stands for Voice or WAN. You could spell that out, Voice or WAN interface card. These things are awesome because these interfaces allow you to connect to either a voice, like we show right here, or a data network. Like if I have a service provider that is connecting to a WAN connection, maybe going to another office or something like that, this can be converted over to a data interface. Chances are, if your organization has bought a router with T1 interfaces in the last probably 2 or 3 years, Cisco has sold you these instead of the old just WIC cards. If you have T1 WICs like this, then they can only connect to WAN interfaces. They cannot do the PSTN connections. And I know it's difficult to see from this image, but these cards are beefy. They actually have, this is a kind of a double-decker card right here. It has like a riser board on it with a second set of chips up here. They're thick cards. And this is a VWIC 2 MFT T1/E1, which gives you 2. They also sell 1 MFT, which just give you a single interface. The point of these is that you can get, using T1 up to 24 channels, or with E1 up to 30 channels of voice communication between you and the PSTN, or you and the legacy PBX system down here. So depending on which flavor you decide to use, CAS, also known in the T1 world as robbed bit signaling, CAS will give you the full 24 channels, but degrade the quality of your voice, not noticeably, but degrade it because it's going to steal or rob bits from the actual voice channel to comprise the signaling. In the data world, most people will use CAS connectivity. That's just common for these kinds of connections. But in the voice world, you got to get used to this because it's a shift if you're a data person. Most people will use CCS. Yes, you sacrifice one of your voice channels. You go down to 23 channels of voice if you're using T1. With E1, you get the same because CAS or CCS, you always have 2 signaling channels, a framing and a signaling channel with E1 connectivity. But in the T1 world, you're down to 23 channels for voice, but you get 1 full channel for dedicated signaling. The reason this is more common in the voice world than the data world is because with, I forgot my close parentheses, with the voice realm, you can send all kinds of proprietary or standards-based signaling over that extra channel. With a CAS connection, you're very limited with the kind of signals you can send. In some environments, you won't even be able to get caller ID if you use CAS, things like that. So CCS gives you a lot more flexibility because you have an entire dedicated channel just to signaling. So these kinds of voice ports are very useful if I need bulk. Lots of voice channels. So, I showed you creating a trunk between your router and the PBX using FXO to FXS or station port matches, but you only get 1 call per port. As you get more and more people over here in the voice over IP realm, and there's a large significant amount over here, you're going to need a bulk amount. So, you can just run a T1 crossover cable between your router and the PBX system to get a full 23 or 24 channels, depending on which one you're using, of communication between them. Now, there's also one, I don't think I've mentioned it up to this port. It's not too common. It's BRI. Basic Rate Interface gives you 2 individual channels of voice. So double an analog interface. 2 voice channels and 1 dedicated signaling channel. Those are good for, just small little connections, giving you 2 voice channels, either to a PBX or to a telco CO or PSTN connection. So we've talked about analog connectivity, talked about digital connectivity, the 2 different kinds of ways that we can connect to legacy equipment, meaning the PSTN, a PBX system, all kinds of different legacy equipment types. Now let's look at one final topic, and that is connecting CME to other voice over IP systems. So we're now moving from our connections using VIC cards, the voice interface cards, and that's digital or analog, over to internet connectivity or IP WAN, essentially staying on the data network. Down here, we have our system as we understand it. We've got our CME router using voice over IP to control our internal phones in here. And we can connect to a variety of other systems. Let me start from the bottom up. I can have a connection over, again, the internet. It could be a VPN connection, could be many different service providers giving me IP connectivity. Then I could communicate over here to another router at another location that connects to a full Cisco setup. We've got a Cisco voice router, no VIC cards going on here, at least they're not shown in this picture, so everything is staying IP based. We're all using voice over IP communication. You communicate over this connection to this Cisco voice router, which then bridges it into the full-blown Cisco Unified Communication Manager system. That's our, the big step up from CME. You could have thousands of IP phones controlled over here, and this is your web-based management system to govern this whole network. This is a Cisco bred IP network between these 2 different devices. Now we could also have a connection over the internet or IP WAN to a heathen router up here, a non-Cisco voice router, which could be a VIA, could be many different vendors of non-Cisco equipment, which connects to their non-Cisco voice over IP system, which connects to their IP phones. Again, we're staying IP from end to end in this scenario where we are never converting from a voice over IP environment to analog or digital connectivity. But the reason I throw this picture in here is, when we're talking Cisco to Cisco, no worries, right? We're all using the same language, we're all using the same kind of equipment, we're all using the same protocols to communicate. Our phones speak using Skinny, the Skinny communication protocol, which is Cisco proprietary signaling method. So it's like Cisco end to end, right? Well, when you get up here, you're getting into other vendors' equipment. They've got their own language to control their phones, and we have to have some kind of common ground to stand on between our network, our voice over IP network, and their voice over IP network. We'll look at what protocols do that in just a moment. The last scenario that we could have is we could have our connectivity to a Cisco or non-Cisco router up here. Again, we're maintaining our IP communication up to here, but then this router could connect to a legacy PBX system using either analog or digital connectivity interfaces, just like we talked about in the previous slides. So once we jump off here, this is truly maintaining the name of gateway, if you will, because it's converting from our voice over IP communication to a legacy language that can now speak to the legacy PBX systems. And this is using proprietary digital communication. This is in the PBX realm. We're in a proprietary lock here. If you're using like a Lucent PBX, these are Lucent phones, Lucent signaling between the different devices. Everything's Lucent there. So we have to have a way of bridging our communication from IP here so that this understands it, and then the gateway has to communicate it back on an analog or digital connectivity method to the legacy system. Here is the common ground we have to stand on between all of our different voice over IP equipment. 3 protocols, 3 voice over IP protocols that are used for gateway control and signaling. So, if I could bring my miniature scale picture back in, we've got our CME router over here. which is connecting to all those different router types. It could be Cisco routers, it could be non-Cisco routers. We have to have a common language to speak between all of these devices for signaling, to pass digits, to signal when somebody hangs up, to do things like conference calls and forwarding and call hold and transferring. All these things require some kind of signaling. 3 different industry standard languages that we can use on Cisco devices and non-Cisco devices alike, at least most of them, that can support and communicate between them. On Cisco routers, the default language when you start configuring it is H323. What H323 has going for it is its age. It is the oldest protocol of the bunch. It has been around the longest. It is tested, it is tried, it is true. It is like the TCP/IP, if you will, of voice communication. Because it's been around forever, everybody's kind of supporting it and using it. But the problem is, this was originally designed when they came up with H323. It was designed for ISDN networks. And they were talking about, I don't know if you remember this, but back in the day when ISDN came out, people were like, this is the future, man. This is totally where everything's going to go. Pretty soon ISDN's going to be everywhere. And, ISDN was like, oh, this is the great new thing. Well, ISDN has reached its age, and we've migrated away from ISDN into other connection types like IP. But H323 was designed for that and then tweaked to work over an IP-based network. So H323 is a massive protocol suite. It does, whiteboard sharing, data sharing, it does video conferencing, it does audio communication, it does everything, so it's a lot of overhead. It's very big, it's kind of cumbersome, and it does a lot of things beyond signaling that we just don't use it for anymore. So it's kind of a clunky, for lack of a better word there, kind of a clunky protocol that it does the job. And I will say it is kind of the common ground that we have. Now, let me talk about this one. I was going to jump to SIP, but MGCP was created by Cisco, but it was released as an industry standard, which is the only protocol that uses a server-client model. And what that means is, let's say you've got all these routers in your network, right? Well, all the other protocols, H323 and SIP, and there's exceptions to this, but they are primarily what's known as peer-to-peer protocols, which means I have to put a full configuration on here saying here's all the numbers that are available, this is how you connect, here's the remote IP address, and on this one I have to do the same thing, here's all the numbers, here's the remote IP addresses, a lot of configuration. With MGCP, I can put Cisco calls it a call manager, but industry standard says this is a call agent. This is kind of your server of the network. And all of the routers become like dumb terminals. There's very little configuration that you have to put on them. They just all look to the call agent for their intelligence. So let's say a call comes in for this router right here, and it says, oh, I just got a call for 5555. Call agent, I got this call. It's going to 5555. What do I do? Call agent looks it all up and says, oh, okay, you need to send it over here. They're going to get it, use this codec, use all of these different standards to communicate. Go ahead and do this. So the call agent instructs that router for what to do. Now, the benefit for that is this is a phenomenal service provider protocol because it gives them centralized management. Instead of putting, all of these different routers with different configurations, you've got one centralized center that gives these devices all the intelligence. But anytime you say centralized, there's your disadvantage. If any of these routers lose their connectivity to the call agent or cluster of call agents, they go down. They become like that dumb terminal and they have no intelligence to communicate. So MGCP works well if you have a good connected redundant network where people are always able to reach the call agent. Now I also say used primarily by Cisco because it's kind of for other vendors, it's kind of a faux pas. It's like, since Cisco created that protocol, we don't want to support it because then we'd be saying Cisco is good. They're not saying that, but that's kind of the feel that you get from other vendors is when you talk MGCP, they're like, oh, well, that's kind of a Cisco protocol. And you go, well, no, it's not. It's industry standard. Well, yeah, but, Cisco is the primary one that uses it, so we don't really support it on our routers, blah, 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 blah. There's other vendors that support it. It's just primarily Cisco. So let's talk about SIP down here. I have my little coffee cup, sip that coffee. SIP stands for the Session Initiation Protocol, and it is designed, the reason I wanted to talk about it right after H323, my mind immediately jumped there, is because it's designed as the next generation H323. They've trimmed it down so it's lightweight. It only handles signaling, not all of the other clunky stuff that H323 does. It is designed to signal between devices and set up calls, whether it's voice, whether it's video, all those kind of things. It is the signaling standard. And I put it is poised currently to be the universal voice over IP standard. The reason I say that is this is kind of comparable to the data world when early on, we'll say, 15 years ago in the data world, I was talking about things like IPX, SPX. I even threw that out in the opening slide of this. Or Apple Talk. You might remember things like this. Apple Talk, NetBUI, this DECnet. The list could go on and on and on of all these different protocols. And if you're new to the data world, you look at those and go, what are those? Well, they were protocols that people used in their networks all the time as almost alternatives, and they were alternatives to TCP/IP, and they had great advantages and disadvantages and all that kind of stuff. But nowadays, everybody's like, yeah, whatever. These are all gone. You rarely, if ever, hear about them because everybody's talking TCP/IP. This is the universal data standard that we've settled on. Well, SIP is poised to be the universal voice over IP standard. It's not there yet because it's not done yet. Meaning, SIP works, it's a standard out there, but they don't have it supporting signaling for everything that we need in the voice over IP realm. There's features that some vendors support that aren't supported in SIP. And what's going on right now is you have, for instance, Avaya. Avaya is a fierce competitor of Cisco in the voice over IP world. They use SIP for everything. SIP for their phones, SIP for their routers, SIP in all their communication. And initially you heard Avaya saying, oh, well, Cisco, they are using their own proprietary protocols. They don't even support SIP, because Cisco actually early on didn't even support SIP because they wanted to give it time to mature. Avaya's like, oh, industry standard, and all the other voice over IP vendors jumped on this bandwagon. Not the Avaya bandwagon, but the SIP one. Everybody started supporting SIP except Cisco. And everybody's like, oh, SIP is the way it's going, blah, 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 all this kind of stuff. But the problem is SIP wasn't done yet. And to get the features that they needed, Avaya and all the other voice over IP vendors wrote behind the scenes, this is behind the shaded curtain there, they wrote their own proprietary plugins for SIP. So, for example, they get, dial tone using SIP. They can do basic, digit send, like DTMF relay, to send digits, dial digits, dual tone multi-frequency, to send them to other vendors using SIP. But then when they got to features like, conferencing, or, just features that are kind of like, oh, these are cool features. Well, SIP wasn't far enough along to have an industry standard way of doing it, so Avaya wrote their own proprietary plugin to handle those features. So what that meant is if you have Avaya phones connecting to, we'll say, oh, I don't know, what's another voice over IP vendor? Intertel, or there's one that Televantage. I keep getting emails for them. Televantage phones. If they both use SIP, sure, they'll be able to talk and communicate using this industry standard language. But as soon as you hit the conference button, or something that Avaya or Televantage has written their own proprietary plugin for, then it's not going to work between these two devices because it's proprietary. So Cisco now does support SIP. They have jumped on the SIP bandwagon, but if you do run SIP, Cisco has their own proprietary plugins. So I always call SIP the half-baked cookie, because when it's going to be fully baked, oh, it's going to be good. It's going to be that chocolate chip, edges are brown, soft center, you just bite into it, it's like awesome. It's an awesome cookie because everybody will be using it, and you'll have true vendor independent voice over IP communication. But right now we're kind of raw in the middle. We've got the edges, they're starting to brown with SIP. It's kind of getting there, but we haven't baked it all the way because there's all these proprietary plugins that are still there. So if you want a full industry standard protocol, these guys are your buckets to use, primarily this one because everybody supports it. But if you want kind of the cutting edge, we're getting there protocol, but it's not quite there yet, that's where SIP comes into play. So that's what I wanted to give you an idea of in this nugget. I wanted to give you an idea of how, what ways do we have to connect our CME router gateway to other voice systems. We looked at the voice gateway types, our analog and digital. We looked at the different analog and digital connectivity, analog being primarily one call per port. You've got your 3 FXS, FXO, and rarely E&M interfaces that you can use to connect to other legacy voice equipment. And anytime you think analog or digital, think legacy, pre-voice over IP. Digital, we've got our T1/E1 CAS CCS, that's the most common standard, common channel signaling, or PRI. And then we have the ISDN BRI connection with 2 calls per port. All those are considered digital connectivity. And then we looked at the protocols, the 3 big ones, H323, MGCP, and SIP, that we can use to connect to other voice over IP systems. So these are all the different standards that we can use. As we move on through the other nuggets, we're going to start looking at the configuration. Here's how you set it up. Here's how we link these systems together. This is just to talk about the protocols we can use and the standards we can use to connect to both of those. I hope this has been informative for you, and I'd like to thank you for viewing.